Good morning, everybody. Today is 7th December 2020, Monday. My name is Ferhan Mazher, and right now I am with the 10 Cambridge class, and we are studying Physics 5054. We are working on the chapter of sound, and we have almost completed this chapter. It will require, I think, one more lesson, and then we will be able to, we can go into then the past paper questions or after regarding the sound. Today, the main purpose of this lesson will be to study about the ultrasound, or we say ultrasonics, ultrasounds. Ultrasounds are those sound waves whose frequency is more than 20,000 hertz. The sounds whose frequency is more than 20,000 hertz, we call them ultrasounds. Okay, so the sounds whose frequency is less than 20, the audible frequency range for the human is 20 to 20,000 hertz. So the sound waves whose frequency is less than 20 hertz, we call them infrasound, and the sound waves whose frequency is more than 20,000 hertz, they are called ultrasound. And you know that the human ear will not be able to hear the sounds which are ultrasound, and the human ear will not be able to hear the sounds which are infrasound. So any sound whose frequency is less than 20 and more than 20,000 hertz, we are not able to hear them, but they are very useful. So today the main purpose is to study about the ultrasounds. Okay, so the sound waves whose frequency is more than 20,000 hertz, they are called ultrasounds. So we have studied that the ultrasounds, when these are longitudinal waves and when they are propagating in a medium, if there will be a change in the density of the medium, it means that the sound waves, when enter from one medium to another medium, then what happens, some of the sound waves are reflected back. So this reflection process of the ultrasounds, we have ultrasounds, we send them in a medium, and when they are reflected back, we can study them, and the sound waves which are reflected back, so we kind of study them with computers, and we are able to describe what is present in that object. For example, ultrasounds, you must have heard this word ultrasound. Is a very famous word used in the medical treatment. If you have ever been to a hospital, they say, okay, go get an ultrasound. So with the help of the ultrasound, what happens, without opening the body, without doing the surgery, without actually opening the body, they are able to see inside the body. The doctor is able, with the help of the ultrasound, the doctor is able to see the organs inside the body without opening the body. And you must have come across this word ultrasound, especially when a mother is expecting and the baby is in her womb, and the doctors do their ultrasound, and without opening the body, they are able to see the image of that fetus. They are able to see the image of the baby inside the womb of the mother, and they can check the growth of the baby. They can check what are the dimensions of the baby. They can check how the baby is growing. They can check his eyes or her eyes, hair, heart. They can see. They can check the lungs, and they can even, which is a very wrong thing, they can tell you the gender of the baby also. This all is done with the help of the ultrasound. So the basic thing is what they do. They send the ultrasound. They have a transmitter. They have a transmitter which is producing ultrasound. So what they do, they send the ultrasound waves into the womb of or into the belly of the mother, and the ultrasounds are reflected from the tissues of the baby. And when they are reflected back, we have a receiver of the ultrasounds, and with the help of the computer, they are able to make the image of the baby. So this is one very important use of the ultrasound in the medical, you see, in the medical field. This procedure, which I just talked about, the ultrasounds, it is very, very important. In paper, it has come many times that you have to write for 2 marks or 3 marks that how the ultrasounds are used for making the image of the fetus. Okay, so in medical, ultrasound imaging used in antenatal clinics to monitor the health and sometimes to determine the sex of an unborn baby. An ultrasonic transmitter and receiver is scanned over the mother's abdomen, and a detailed image of the fetus is built up. The figure is also shown here. You can see this figure. You see this figure, the doctor is able to understand. We will not be able to understand it and see the details and conclude anything. But the doctors are able to understand this image. Okay, this is the image which is formed by using an ultrasound. You can see a fetus is shown here inside the womb of our mother. So, reflection of the ultrasonic pulses occur from boundaries of soft tissue. In addition to bone, so images can be obtained of internal organs that cannot be seen by using X-rays. Less detail of bone structure is seen than with X-ray, as the wavelength of ultrasonic wave is larger, typically about 1 millimeter, but ultrasound has no harmful effect on human tissue. The one very good advantage of using the ultrasound is it has no harmful effect on the human tissue. X-rays, on the other hand, they are used to image the make the image of the bones, but the X-rays are very harmful for the human cells. Okay, so these sentences you have to write in the answer. You see, they ask you question that how the ultrasounds are used in the medical field, and then you have to write these answers. Another very important use of the ultrasound is ultrasonic echo technique. Ultrasonic echo technique is simple. You see here, here I have a figure. Let me show you. You see here on your screen, you can see we have shown a ship, and that ship has an ultrasonic. Walaikum salam. So in this ship, we have an ultrasound transmitter. So what that ultrasonic transmitter will do, it will produce ultrasound pulses. So those ultrasonic pulses will be sent out, and from the bed of the ocean, they will be reflected. And on the ship, we have a receiver for the ultrasound. So if you know, you see, if you know the speed of the ultrasounds.
Yes, sir, we can hear. Yes, sir.
Okay, so we were talking about how if you know the speed of the ultrasound in the water, and you know the time taken for this transmitter to send, the time taken for the ultrasound to go to the seabed and then come back. You simply multiply speed with the time, and whatever the distance you get, divide that distance with 2. And that will give you the depth of the ocean at that point. We will do numericals on this topic. Do you understand this idea?
Yes, sir.
Okay. So another very important, you see, bats, you must have heard the word bat, the bird bats. Bats, they are mammal basically. Bats are they produce ultrasound. When the bats are flying in the night, or even during the day, when the bats are flying, what they do, they produce ultrasounds. And those ultrasounds go away from them. And if something comes in their path from that object, the ultrasounds are reflected and come back. So the bat has a transmitter of the ultrasounds, and bat also has the receiver. So when the ultrasounds are reflected from an object in their path, so when the bat receives the ultrasound back, the bat's brain can process and it can tell that what is the shape of the object, how wide it is, how high it is moving towards the bat, or it is moving toward away from the bat, or it is stationary. So you see, the bat use these ultrasounds. It produces ultrasound, it sends out ultrasounds, and the ultrasounds are reflected. And when they are received back, the bat is able to take its path. So the bat use this technique. The ships also use this technique to find the depth of the object, the depth of the sea, or the depth of the bed of the sea. Ultrasonic waves are partially or totally reflected from surfaces at which the density of the medium changes. This property is exploited in techniques such as the non-destructive testing of materials, sonar is the name of the technique, and medical ultrasound imaging. A bat emitting ultrasonic waves can judge the distance of an object from the time taken by the reflected wave or echo to return. Ships with sonar can determine the depth of a shoal. Shoal means the group of fishes, of fish or the seabed. In the same way, motion sensors also work on this principle. Okay, so this is the ultrasounds and other uses. This is very important. The other use of the ultrasound. You see, the it's also from the exam point of view. This is also very important. The ultrasounds are used for the cleaning purpose. The ultrasounds are used for the cleaning purpose. What we do, we take a utensil, and in that utensil we put the cleaning solution. And for example, if you have jewelry and you want to clean that jewelry, so this technique can be used. You take a utensil, you put the cleaning solution in it, and you put the jewelry in the cleaning that utensil, and then you use a transmitter of ultrasound, very high frequency ultrasounds. And when that transmitter produce ultrasound in that water, the vibrations are produced in the water. And those vibrations, they will dislodge any kind of dirt or any kind of unwanted material in the jewelry. And when the ultrasounds are produced in that solution, the cleaning of the jewelry can be done. The dust particles which will dislodge from the jewelry. So you see, the ultrasounds can be used to clean different objects. For example, the ultrasounds can be used to clean the jewelry. So it's very important. Its uses are very important, to know them, to list them, to state where they are used. Sometimes you have to describe how they are used. Ultrasound can also be used in ultrasonic drills to cut holes of any shape or size in hard materials such as glass and steel. So they are also ultrasounds are also used to drill holes. Jewelry or more mundane objects such as street lamp covers can be cleaned by immersion in a tank of solvent which has an ultrasonic vibrator in the base. You see, this question, how the jewelry is cleaned, has came many times in the paper. Okay, so this is ultrasounds and their uses. I would like to this seismic waves, when you have time, kindly read this article also. Seismic waves are the waves which are produced by the earthquake. So earthquake produces both longitudinal waves, we call them P waves, and transverse wave, we call them S waves. You must have heard these words, S waves and P waves. that are known as seismic waves. They travel through the earth at a speed of up to 13,000 meters per second. You just read this article, okay? When seismic waves pass under building, several structure several structural damage may occur. If the earthquake occurs under the sea, the seismic energy can be transmitted to the water and produce tsunami waves that may travel for very long distances across ocean. As a tsunami wave approaches shallow coastal water, it slows down and its amplitude increases, which can lead to massive coastal destruction. This happened in Sri Lanka and Thailand after the great 2004 Sumatra Andaman earthquake. The time of arrival of the tsunami wave can be predicted if its speed of travel and the distance from the epicenter of the earthquake are known. It took about 2 hours for tsunami waves to cross the ocean to Sri Lanka from Indonesia. A similar time was needed for the tsunami waves to travel the shorter distance to Thailand. This was because the route was through shallower water and the waves traveled more slowly. If an early warning system had been in place, many lives could have been saved. So you just need to read this article. That's it. Okay. So
Sir,
I
please could
want
you give
you
the
to.
article?
This article is showing on your screen right now.
Okay, sir, we will read it from here.
I can share this book also. I have this PDF book in with me, so we can do this. I can share this book with you. Okay.
Thank you.
Another the use of the ultrasound is very important. That's why, and it's not that difficult. I want you to read this also. So, what is ultrasound? Some of the frequency higher than 20,000 hertz, which are inaudible. The human ear cannot hear them. To normal human ear are called ultrasound or ultrasonic. Uses of ultrasound. Ultrasonic waves carry more energy and higher frequency than audible sound waves. Therefore, according to the wave equation V is equals to F lambda, the wavelength of ultrasonic wave is very small and is very useful for detecting very small objects. Ultrasonics are utilized in medical and technical fields. In medical field, the ultrasonic waves are used to diagnose and treat different ailments. For diagnosis, different diseases, ultrasonic waves are made to enter the human body through transmitters. These waves are reflected differently by different organs, tissues, or or
Sir, can I
tumors.
ask a question?
Sorry,
Sir, can I ask a question?
yeah.
Sir, as we know that the ultrasounds are used in medical purposes to see in towards the body, inside the body. So how does this sounds help to see inside the body?
Ultrasounds are sound waves actually. They are reflected from the tissues. So when the computer, this is not done by normal human naked eye. No,
Ji
the
sir.
ultrasounds are reflected. They are sound waves. They are reflected from the boundary of different tissues, and the computer makes an image. Okay.
Okay, sir.
Okay.
So is it like the reflection of light and this is the reflection of sound? I think so.
Yes. These waves are reflected differently by different organs, tissues, or tumors, etc. The reflected waves are then amplified to form an image of the internal organs of the body on the screen. Such an image helps in detecting the defects in these organs. Powerful ultrasound is now being used to remove blood clots formed in the arteries. You see, very important use. Sometimes you have to write the uses in your paper. Powerful ultrasound is now being used to remove blood clots formed in the arteries. Ultrasound can also be used to get the pictures of thyroid gland for diagnosis purposes. Ultrasound is used to locate underwater depth or is used for locating objects lying deep on the ocean floor. The technique is called sonar, sound navigation and ranging. Sonar stands for sound navigation and ranging. The sound waves are sent from a transmitter and a receiver collects the reflected sound. The time lapse is calculated. Knowing the speed of the sound in water, the distance of the object from the ocean surface can be estimated. So here you see the technique is being used. Here the doctors are doing the ultrasound, and sonar ranging is also used to see the shape and the size of the object. Cracks appear in the interior of moving parts of high speed heavy machines such as turbines, engines, or ships and aeroplanes due to excessive use. These cracks are not visible from outside, but they can be very dangerous. Such cracks can be detected by ultrasonic.
Excuse
A
me, sir.
powerful, yeah,
Sir, can we use the ultrasound waves or ultrasonic waves to see through a wall?
see through a wall. I think we can do that. You see, the ultrasound, they can, the wall is little denser, but for example, the ultrasound can, they can pass easily through this skin tissue. And ultrasound will be able to pass through the, I think they can pass.
Sir,
Yeah.
sir, ultrasounds are used to see if there is a cavity in a concrete block or inside a wall. It cannot pass through because
For
we don't
example,
need to make them pass.
yeah. For example, if you have a wall of a dam and that dam wall is like 6 meter thick, and
No,
inside
sir,
that
normal wall.
wall there is a crack inside the wall. So you will not be able to see it from outside. So what we do it's ultrasound. And if there is a cavity inside a wall which is 6 meter thick, a dam's wall, and
Sir,
if
is
there
the
is a
thermal,
cavity inside the wall,
sir, is the thermal vision also concerned with this ultrasonic waves?
no, the thermal imaging is done based on the infrared radiation.
Sir, please could you repeat? There was some noise.
Ultras, ultrasound use sound waves, but the thermal imaging is done based on infrared radiation coming from the hot bodies.
Okay, sir, got it.
So, if there will be a cavity inside the dam wall, so for example, a 6 meter thick dam wall, and there is a cavity inside. So from outside, everything seems good, but there is a cavity inside, which is a weakness, and that can be very very dangerous. For example, if you have an engine of an aeroplane, and that engine is sealed, and if there is a crack inside its cylinders, there is a crack and you cannot obviously see the crack from outside. So what they do the ultrasound of the engines after a few after some flights they do the ultrasound, and they if there is a crack inside they will be able to see that crack by the ultrasound. Okay, these cracks are not visible from outside, but they can be very dangerous. Such cracks can be detected by ultrasonic. A powerful beam of ultrasound is made to pass through these defective parts. While passing, these waves are reflected by the surface of these cracks and flaws. The comparison of the ultrasonic wave reflected from cracks and from the surface of these parts can give a clue of the existence of the cracks. Germs and bacteria in liquid can also be destroyed by using the high intensity ultrasonic waves. So you see, today I have read these. You see, you will see. There's not that much explanation, but to read these articles where he defines how the ultrasounds are used is very important, because sometimes you have to list the uses of ultrasound and sometimes you have to use them. So I have time still. So let's do a question for how the ultrasounds are used. Okay. On your screen, let me increase the size. You can see. So you can see more clearly. Okay. So let's do these questions. Okay. So here are some questions in that book regarding sound waves. Okay. He says if 5 seconds elapse between a light flash and the clap of thunder, how far away is the storm? Very easy question. You see how I will do this. Let me show. Okay. So you know the distance is equals to how what? Distance is equals to speed and
into time.
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 Okay. So what is the speed of the sound? That is 330. And how much time the sound took to reach there? He said
So it's
five
5
seconds.
seconds.
Yeah. So simply multiply them and you will get the answer. You have a calculator?
1550.
Okay. 330 multiply 5.
16.
And the answer is
1650.
1650. Yeah. 1650 meter. So that flash actually happened 1650 meter away. Do you understand?
Okay,
Do you
sir.
understand, America?
ठीक. Yes, sir.
Okay. Let's do the next one. A girl stands 160 meter away from a high wall and claps her hands at a steady rate so that each clap coincides with the echo of the one before. If her clapping rate is 60 per minute, what value does this give for the speed of the sound? Okay, so in 1 minute she is producing how many? A girl stands 160 meter away from a high
60
wall and
claps.
claps her hands. So at a steady rate, so that each clap coincides with the echo of the one before. If her clapping rate is 60 per minute, what value does this gives for the speed of the sound? Okay, let me do this. Let me open up. Okay, so let's do this here. Okay, so she is actually doing 60 claps per minute. So the time required in seconds. So she,
So one
so
clap per 1 second.
the time is 60 seconds, and claps are how many? There are how many
So
claps?
60 claps
60 claps.
a
Okay.
minute.
60 claps.
So in 1 minute she is doing 60 claps. So what is the time between one clap and the other clap? So that
One
Sir,
actual
1 second.
second.
time,
1
time
second.
for one clap, yes, one clap. That will be equal to 60 divided by 60, and it will take 1 second. So if you read that statement very carefully, you will understand in 1 second, when she claps, in 1 second the sound waves go and reflect from that wall and come back. Okay,
So, sir, it means
and
we'll
that
multiply
wall is
160 with 2.
160 meter away. So the speed of the sound will be the distance traveled by the sound wave and divided by the time the sound wave take. You see, in 1 second she is doing one clap and she is coinciding her claps with the echo. So it means in 1 second the sound wave, the clap and the sound wave goes, covers 160 meter distance and comes back. So the total distance covered by the sound wave is 160 plus 160. 160 in going and 160 in coming back. So the total distance covered is 160 plus 160. So it will be something like 320.
320.
So the total distance covered is 320 and the time taken is 1 second. So the speed will be 320 meter per second. That will be the speed. Do you understand this?
Yes, sir.
Okay. So let's move to the next question. He says if she moves 40 meters closer to the wall, she finds the clapping rate has to be 18 per minute. What value do these measurements gives for the speed of the sound? Okay. Now she has moved. He's doing uh, the same data that she was 160 meter away from the wall, and now she has moved 40 meter closer. Okay, let's do this. Let's put it here. Okay. Now the distance between her and the wall, distance between that girl and the wall is now 160 minus 40. Okay, she has moved 40 meter closer to the wall. So now the distance is 120 meter. Okay. So now this time, what is the time? He noted on the for 60 seconds. And how many claps are there? The claps are 80. So what is the time for one clap? What is the time between one clap and the other clap? That will be 60. Let me call it time. Time for one clap. That is time between one clap and the other clap. That will be 60 divided by 80. So what is the answer? 60 divided by 80.
So I think so 0.75 minus
60
Yes,
0.75.
sir. 0.75.
and it is 0.75. Okay. 0.75 seconds. So this the the time between two claps is 0.7 seconds, 75 seconds. You see, try to understand this.
So to match the
In
echo.
0.75 seconds, the sound by the clap, the sound is produced. It goes 120 meter away to the wall and 120 meter back. So the sound basically is covering 120 meter going and 120 meter coming back. So the total distance covered by the sound, that will be 120 plus 120. You see, when you clap, the sound waves are produced, they go to the wall, and from there they are reflected and come back. And when you hear the echo, he coincides the second clap with it. So the sound took 0.5 seconds, 0.75 seconds to go to the wall and come back. The distance covered is 120 meter going and 120 meter coming back. So the speed is equals to the distance traveled and divided by the time taken. And you know the distance traveled is 120 plus 120, that is 240. And you divide it with the time taken, that is 0.75 seconds. And if you have the calculator with you have your calculators. So
Yes, sir.
240 divided by
Sir, again
0.75. You can do
320.
also on the calculator 320. Oh, again, the speed is still 320. 320, sorry, 320 meter per second. That will be the speed. Do you understand this thing? It's a O-level style
Yes, sir.
question. Yeah. So it's good.
Yes, sir. It's easy.
If the C part is if she moves again and finds the clapping rate becomes 30 per minute, how far is she from the wall if the speed of the sound is the value you found in the A part? In the A part, we found the value of the speed is 320. Okay. Okay. Now this C part, you see, it's a little tricky making it. Now we have to find out the distance between her and the wall. Okay. Now let's see. Now the rate of clapping is there are how many claps? There are the number of claps are 30, and this is happening in 60 seconds. So what is the time between one clap and the other? Uh, this time for one clap, that will be 60 seconds divided by the 30. and you will get how much? 60 divided by 30, that will be 2 seconds. Okay.
Yes, sir.
Okay. So we don't know the speed of the, he said speed of the sound is that which you found in the A part. That was 320 meter per second. So I have to use that speed. So I know the time of for the sound wave to go and come back. So the distance will be, the distance is equal to, the speed multiply time. And I know the speed. That's 320, and I will multiply it with the time. That's 2 seconds. So let's get the answer. 320 multiplied 2. It will be 64, 64
640.
640 meter. But this is the 640 meter is the distance traveled by the sound wave in going from the hand to the wall, get reflected and come back. This 640 is the distance which the sound wave covered. When you clap, the sound wave produced, they go to the wall, reflected, come back. So that's going and coming back. That's the total distance, 640 meter. So the distance between the girl and the wall will be the distance between girl and wall. That will be equals to half of that thing. So what will be the
640
answer?
divided by 2.
So
320 meter per second.
she is 320 meter away from the wall right now. Do you understand this, numerical? How far is she from the wall if the speed of the sound is the value you obtain? Do you understand? You see how he played with you. Try to confuse you. Okay, so see this question number 4, it's B part we can do. He says if the speed of the sound is 340 meter per second, what is the wavelength of the note of the frequency? Let me do this. Okay, so we know that V is equals to F lambda. It means the speed is equals to frequency multiply wavelength. You know that?
Yes, sir.
Eh? V is equals to F lambda. Spelling of length. Oh God. Length. Okay. Now we know this formula. V is equals to F lambda. So I know the speed. That's 340 meter per second. And the frequency in the first part is 340 hertz. And the wavelength is the question.
So
Okay.
then obviously the answer is going to be the one.
The wavelength will be 1 meter.
One.
Yeah. It will be 1 meter. You understand this?
Yes, sir.
And if we do the second part, the speed is 340 and the frequency is 170. So what will be the wavelength? So the wavelength will be, how much will be the wavelength? Do the calculation. So the wavelength will be equal to how much? 340 divided by 170.
Sir, sir, 2 meter.
It will be 2. Yeah, it will be 2 meter. Do you understand this numericals?
Yes, sir.
Okay. So in the chapter of sound, the numericals which are related with the echo and the numericals which are related with the ultrasound, they are very important. We will do another session on the numericals related with the ultrasound, and then you will be good to go to do the practice of the past paper related with the sound. So I think it's enough for today. and hope that everything is clear. And during our session, once the internet went down, due to that, we have an interruption in our lesson. Otherwise, that everything went good. I hope that you have understood it. We will do another session on ultrasound. We will do the numericals on the ultrasound and we will do the numericals on the echo. They are very important for O levels. Okay, they come in paper. So you thank you very much and have a good day. God bless you all. Thank you.